I am going to be, actually, it's unfortunate in some ways that these talks that I'm going to give two talks. So hopefully you won't get tired of me, but they should have been flipped right now, I see, because the second talk I'll be giving follows on beautifully from what Rafi just talked about. But I'll try to remind you as I go on that one talk. But modified streams, particularly physically modified streams, also gets into this sort of causal assessment kind of area. Although here we oftentimes may know at least some of the stressors, but the difficulty there is a little bit different of kind of identifying them and really characterizing them and then looking at what's the biological expectations associated with them. I just want to, before I get going, I just want to acknowledge especially Ruth Kolb from the city of San Diego, who has been a champion of really trying to further advance the science of bioassessments and its use. And bioobjectives. So she's really helped fuel quite a lot of the work we're going to be talking about. So let's see here. All right, so basically there's lots of ways to classify streams, and classifying streams can be very important when you're trying to figure out biological expectations. Again, I'm only going to be talking primarily in this talk about the modified status, and I'll get into that in a second. There are many relevant classification factors, and we've been looking at this very much in the work that we're doing with the city of San Diego for the Southern California region. So this, what I'm talking about here, is just one part of that, that process that we're looking at. As far as physical modifications, many of you are familiar. There's lots of different kinds. We are really primarily going to be talking today here in this talk about physical modifications. We know, because there's hydrological modifications, and sometimes they go hand in hand, but primarily for this talk, we're going to be focusing on the physical. So things like this, okay, where you have, for example, concrete lined bottoms, you have, very clearly channelized stream banks that are artificial, again, all sorts of channelization going on. And maybe low-head dams, and there's other features that are clearly physically modifying the channel. Those are the kinds of things we're primarily interested in identifying and then eventually characterizing. And again, of course, obviously, like I said, a lot of these have hydrological implications as well. We are pretty much focused on what we call Ecoregion 85. This is the southern coastal Zurich region. And I'm going to be talking about two methods. One is a GIS-based desktop analysis using NHD+, and so I'll go through that. And then another method where we're looking more on a site-based as opposed to a broad reach-based. So we found both have utility, and hopefully you'll see why. This is a flow chart which you can't read, and just to say that we have gone through a lot of criteria to figure out how do we use these approaches to identify what we think are physically modified streams and be able to map them and so forth. So this is available, I mean, in our reports, and I think they're going to be available and people can look at them eventually. Let's look at some of the criteria that we're looking at. Downstream of a dam, we assume that basically if you're within a certain distance downstream of the dam, chances are it's in some way modified. And so we considered that as part of the criteria for looking at this. We also looked at a few different kinds of either land cover or geomorphic metrics. The sinuosity is one, and I think somebody mentioned that earlier today. And it's a pretty well-known feature. The more more sinuous a stream is, given a certain stream order or size, you would tend to have a certain amount of sinuosity. If it's more straightened, it's generally going to be probably artificially modified. Land cover changes, whether you're talking about more urban or ag associated around that stream, that may be associated with certain modifications. We also looked at certain physical habitat metrics where we could when we looked at the site basis. But I also want to point out the spatial scale thing. I will be mentioning that in my talk. That's something that definitely is something worth, I think we're going to be exploring further. about just what sort of spatial scale, reach, site, catchment, do you really need to look at some of these metrics, and how do you look at that? So this is a table showing the criteria that we use. Again, this is for the reach-based method, where we're using the NHD plus layers. And so we have sinuosity, and I'm not going to go through all this, but basically where you're going down the table, you're getting more and more into modified or likely modified. And then where you have natural land cover within 20 meters of the buffer, where you have pretty sinuous streams, and you can see we broke these out by stream order because it does vary. That will basically determine, we decided, based on assumptions here, that whether or not you have a natural or likely natural channel that you're looking at versus a modified one. So where you have more ag or developed land, or where you have much less sinuosity, where this channel is almost like basically it's linear, chances are good that it was probably not naturally that way, and it's probably modified. So that's how we basically did this. I just want to call your attention to the unknown category. The unknown in most cases here was due to the fact that we basically had conflicts in some way. In other words, between some of the metrics. In other words, it might have been not a sinuous channel. It was very apparently straight, but had what looked like natural land cover according to the GIS. So then we were less certain as to just how to classify it. So those are probably things we need to look at more in the future. But we're able to actually map this. This is, again, the region we're looking at. This is the border with Mexico. And basically anything that's red there, it was classified as modified, and then orange or yellow would be likely modified, and then the blue would be likely natural. So we have, probably not surprisingly, quite a lot of modified streams according to this analysis. We were able to go back actually and sort of ground truth this some. We need to do more of that, but we were finding that we were pretty good. That actually a lot of what we thought was modified, I think would have been, most of you would have considered modified. So that's this is a summary basically of what we found using the reach-based approach. That's the one method I'm telling you about. And it's interesting because we actually have, according to this method, a fair amount of natural or likely natural channels, but it's probably, there's definitely more that we found on the likely modified or modified. But we have a healthy amount of uncertain, about 20% of the total reach length that we looked at. We were not sure. So not bad, we thought, but again, there's probably room for improvement here. But it was very encouraging, though. But it does show there's a lot of modified streams probably there. So now that's the first approach. The second approach was more of a site-based approach, and it was what we call the weight of evidence approach, where we basically were using the physical habitat or PHAB information that was available for the site, as well as then some of the other metrics I went into just earlier. And then we try to put that together, and I'll show you how we did that. So we have things like, these are the metrics we basically use from the various measures that are used in the PHAB assessment. We use the channel alteration, sediment deposition, and embeddedness, primarily because the literature showed these were pretty well connected with what's modified or not. And we then came up with our own kind of thresholds for these different narrative status as far as modification goes. So, for example, with channel alteration, which goes from 0 to 20, the higher the score, the less altered the channel. So your natural would be the higher scores, your modified or likely modified would be your much lower scores, and so on. And so there you can see how we also looked at dominant land cover in the area of the site. So basically as you got to your more urban, suburban, we kind of classified that as likely natural or likely modified or modified. And then we also have these reach-based data, again, much like we had before, with the sinuosity, land cover. We also included dams present as before, and then the MS4 channel, stormwater channel material, which really we only used here, where where the GIS layer for this. We didn't have a lot of data, but the city of San Diego did have a GIS layer for this. And we were able to, at least in some cases, determine whether there was like concrete or rock basket size or channel of the channel. That would certainly tell us something about this. So we use these kinds of metrics similar to the reach base I showed you before. And so that's what we would use in addition to the PHAB. So what do we do with all that? Well, with this second approach, we basically categorized and each piece of data for each metric. They got a score based on its modification, its narrative that we had across the top, and then those scores are summed to create an aggregate site score, and then we broke out those scores as far as how they should be classified according to whether they are natural, likely natural, modified, or likely modified, and so on. So I think, and here's the way we scored it. So the scores go from -1 for being natural to +1 for being modified. I can only tell you that we must have spent a month trying to figure out the scoring thing here to make it look like it was going to work right. And I think this does seem to work. But basically then the aggregate score column, that's what we're actually using then to figure out where are we going to classify this here. So I'll show you an example, I think, in the next slide. So this is just an example from a site where here's all of our metrics, okay, that we're talking about for the site. You have your PHAB, and then you have these other reach and other measures. Here's the values we actually got for that site. So for example, channel alteration that score was pretty high. So it would be a likely natural. Likely natural gets a score of -0.5. That's how that works. And so on down the line here. Each one of these, if it's likely modified, it gets a 0.5. So any likely modified gets a 0.5, modified gets a 1, and so on. And then you just total this up. All right, so it's equal weighting here, as I said. That's something we want to probably look at a little further, whether they should be equally weighted. But for now, that's how we did it. So this whole site got a score of 1, which unfortunately means uncertain in our way of scoring this. And the reason is because, if you look at it, you're seeing lots of different conflicting sort of things here, where some of these metrics are telling us it's natural, likely natural, and others are telling us they're modified. And so when you do the math, it just winds up being a wash. So it's got to be hopefully one or the other. It's modified or natural, but that's going to need some more work, but at least shows you how we did this. And then this is a summary of what we got using just the weighted average, weighted scoring that we did there. And that basically, again, we got quite a few sites in the natural, likely natural. I think we were dealing with almost 400 sites here in the ecoregion. In the modified and likely modified, somewhat less actually than in the natural based on the sites. Quite a lot in the uncertain category. Okay, so again, this needs a little bit more refinement, obviously, but it's a first. Again, it's a first cut. And then over here, what we tried to do then was, well, all right, how did the site-specific or the site-based approach compare with our classifications using the reach-based approach? That was the first approach I showed you. And actually, the agreement wasn't bad. The ones that we said were natural by the reach method were mostly natural by the site method. Okay, and so on. Where it really broke down, I thought, was when you start getting into the likely modified and the modified, there we have a lot of uncertain sites. So it seemed like the uncertainty seemed to be almost biased more to not recognizing modified sites when we were using the site-based method, as opposed to the reach-based method. So we think we know reasons for that. But we also think that there's probably value in doing both approaches, since you do have that PHAB data, which should be useful, on a site basis. A lot of the disparities we do see here have a lot to do with the reach length. The reach length we were dealing with at the NHD plus layer is on the order of kilometers in some cases, sometimes quite a bit. So you're averaging an awful lot of things in that reach there, which is quite long, whereas the swamp reaches that are usually often used for the sites, are on the order of, 100, 200 meters maybe at the most. So you're dealing with a difference there in terms of the reach length, and that's quite a bit of the reason for this. What we also wanted to do, though, was also look at, well, can we say anything about the biology that's associated with the classification status that we had? And this is based on now the site method. So that's weighted average that we're using here. And basically there, it was encouraging using the CSCI. I don't look too hard at the number of sites on the x-axis, because there aren't many. And we're trying to hopefully bolster that a little bit, but it sure looks good right now. We're basically your natural and likely natural sites have CSI scores where you might expect them, close to 1. And then as you get to likely modified, they decrease, and modified, even more so. The unknown, of course, are everywhere, naturally, because, again, they're uncertain. We have no idea. They include sites that can go anywhere from very modified to very natural. So we need to, of course, tease that out better. But we're hoping to add more sites. We think we can, and also do a better job trying to match up the reach length thing so we can really home in on a little bit better agreement, hopefully, between these different metrics that we're using to classify them. But it looks it's encouraging that we think we have. It's going in the right direction anyway, so that's nice. So the next steps, we want to keep evaluating the most accurate indicators of stream modification status, and part of this is the spatial scale thing. I did not present the catchment information. That gave us some other interesting insights into all this, and so we plan to, I think, do a little bit more with that and try to look at, well, what's the right scales, and then also we wanted to look more at the biology, the macroinvertebrates, but also algae metrics and measures along with the macroinvertebrates to really see if we can come up with some good idea of biological expectations given certain physical modification status, and actually really do a little more ground truthing on this. So I think that's all I have. Let's see. Yeah. Oh, I want to show this slide. Jim gave me this picture years ago, and it's just fascinating because this is clearly a modified stream by our way of looking at it. And yet you see this broken, channel here, right, with all sorts of things, and actually quite a diverse macroinvertebrate assemblage here. Yeah. Yeah. So it defies everything that I just told you, basically. And with that, I'll stop. If there's any questions, I'll take them.